Welcome everyone. In this session, we are going to solve another DSA problem which is titled as largest subarray with zero sum. So let's try to understand what is the problem statement. You will be given a integer list, let it be ARR, so which contain both positive as well as negative numbers. Okay, and it's also not mentioned that it is sorted or anything, so it can be in any order. For example, let's take 15 minus 2 2 minus 8 1 7 10 23. What you have to do is that you have to identify the longest subarray where the sum equal to 0, and we have to return that particular length of the longest subarray where the sum equal to 0. So in this particular example, I can straight away give you the answer. So the longest subarray in this particular example, that the sum going to be equal to 0 would be minus 2 2 minus 8 1 7. So you can compute the sum here. Minus 2 2 get cancels, 7 plus 1 8, that will cancel with minus 8. So what we have to return here is that it's the length of this thing. So the output thing which you need to return would be 5. That's the length of the subarray. So how can we calculate? Like right now we have provided with an answer, but how can we arrive at an answer? So one of the brute force method is to generate all the subarrays and see whether that particular subarray like adds up to a sum equal to 0 or not. If it's equal to 0, the sum is equal to 0, then like see its length and store it or update to a variable max length on comparison with existing max length and the current max length which we have already observed. So that's how we can solve the brute force. So that would be something like first fix max length equal to 0, then one loop which is going to run throughout the range of n. Here I am not writing everything in detail. The n is nothing but the length of ARR. And what you have to do here, you have to like use a variable s equal to 0 and use another variable j to iterate in range of I plus 1 or I. You can start from I also to n. So this will take care of all the subarrays while iterating, and we have to update s plus equal to ARR of j. At any point if s become equal to 0, then that time update the max length on comparison with the existing max length. And what is the length right now? That is nothing but j minus I. Because it's a 0th indiced array, we have to add a plus 1. And at the end, we just have to simply, once entire for loop gets over, we just need to return. Don't forget to give the proper indentation, max length. So what is the time complexity in this particular example? Here there is two back-to-back loop happening here and here. So the time complexity in this brute force method would be order of n square, and space complexity with order of 1. We are not utilizing any extra space. But the question is there any better way or a better solution? Yes, we have already seen a similar problem like subarray with sum equals k. Like that, we can use the concept of prefix sum and hash map to solve this particular problem. So how can we solve that? So what we can do, we can keep on like appending the prefix sum respect to a particular indices we are at. So you can refer to that particular problem like subarray with sum equals k to understand that particular problem. So we can, with that intuition in our mind, we can go straight away to the better solution. So let's write it properly. Class solution, this is the method name, max length. So these are the arguments. So let's try to solve. I just need a hash map. This is nothing but a dictionary. Then what I want is a prefix sum, initially fixed to 0, and the max len which we need to update regularly. Now just iterate. For I in range of length of ARR, add the prefix sum. Prefix sum plus equals ARR of I. At this stage, if prefix sum equal to 0, this is going to be the large subarray that where the max length is equal to 0. There you can straight away update max len nothing but I plus 1. Plus 1 is because it's a 0 based indiced array calculation. And if it's not the case, we should check if prefix sum already seen in the hash map or not. If prefix sum in hash map, if we have seen it already, that means we have just surpassed a subarray that can exist in between somewhere. So there we need to check whether the max len, the length is bigger than what existing max len or not. So max len should be updated such that maximum between, maybe before writing this step we can write, let's keep it empty for now, but we should see how we are updating the hash map. I'm keeping a space intentionally here. I'm going to fill it. So if it's not that case, this is how we are going to like make the hash map. Hash map of prefix sum equals the indice. So if we have seen the prefix sum, this is prefix sum already in the hash map, that means there exists a subarray somewhere in between. Okay, and using the indices, that's stored as a value in a key value in a dictionary, we can calculate the length and we can compare with the existing max len. So the updation would happening like max len is equal to maximum between, compare between max len and I, that is the existing indices, minus hash map of which we have already seen, okay, of prefix sum. So that's how we are going to calculate. And at the end, once this is over, we just need to return max length. So what is the time complexity here? So how can we calculate, or what can we do here? So since we are just iterating once and you making use of the dictionary, the time complexity here is nothing but order of n, but the space complexity is also order of n, because we have utilized the dictionary for the extra space that required to store the prefix sum and the corresponding indices where the prefix sum has been calculated so far. So that's what the technique is all about. So we have discussed the brute force as well as better solution for the problem of large sum array with zero sum. I hope you understood. So thank you for listening.